Okay, in 1987 AB3 we have this region which is 64x to the 1/4 and the line y equals x. Well, basically this is the parent curve there would be x to the 1/4 or the fourth root of x, which is kind of like a square root of x, and it's just going to be taller, a little taller and higher than that. We have the line y equals x. So let's just say that those two curves look something like that. Excuse me, and they intersect at the points. We'd have to find out where they do intersect. So we set up 64x to the 1/4 equals x. We raise both functions to the fourth power, so that 64x equals x to the fourth. We'll bring everything to one side, set it equal to 0, factor out an x. We have a difference of cubes there. Now, if you can just remember that the difference of cubes is going to start out with x minus whatever number is being cubed there. That's really the only two zeros that you have to worry about are at 0 and 4. The whole other expression has no real zeros to it. So this whole expression has only two real zeros, and they're at x equals 0, x equals 4. And so we have the 2 points of intersection as 0, 0, and 4, 4. Now we want to revolve this around the x-axis, which we're getting pretty good at. This is going to be washers again, and it's going to look something like that. And remember, washers are pi capital R squared minus pi little r squared. So we have pi times the integral from 0 to 4. In this case, capital R is the fourth root function, and so we want to square that. That's going to become 64x to the 1/4 quantity squared, which is just 64x to the 1/2 now. And so we get 64x to the 1/2 minus x squared. Now that 64 we can take out, that's really square root of 64x, which will bring out an 8. So we could make 8 squared of x, or 8x to the 1/2 minus x squared. And at this point we're ready to integrate. And 8x to the 1/2 becomes 8x to the 3/2 over 3/2, or 2/3 times 8x to the 3/2. So the antiderivative of 8x to the 1/2 is just 16/3 x to the 3/2. And then x squared is going to be x to the third over 3. And that is from 0 to 4. So we're going to get pi times, to evaluate x to the 3/2 at 4, let's start from the square root and then raise to the third power. So you're going to get square root of 4 is 2, 2 to the third power is 8. 8 times 16 is 128 over 3. And then 4 to the third is 64 over 3. Again, noting that the second term, or the second expression, does become 0. And so we're simply going to have 64 pi over 3. For part B, we're going to set up but not integrate the same region revolved around the y-axis. And I'll scroll up for that. Again, we're starting with our same intersection of two curves, and this time we're going to revolve around the y-axis. And let's assume we got a cylindrical shell that looked like that. Remember that a cylindrical shell is 2 pi rh. So we start out with 2 pi times the integral from 0 to 4. R, the radius, is always x. And h is just going to be the difference of the two curves. And that is just 64x to the 1/4 minus x. And that's all times x in the integrand. And so that's how we set up the cylindrical shell's integral to find the volume of that solid. And you notice that that would be a kind of a cone shape on the outside, but the inside would be kind of inverted. And that's all that we need to do for part C there.